I hate to keep repeating myself, but these are cool problems. The next set, this is lesson 4, and it's going to be, I'm not going to tell you what it is. We're going to go into it. Okay, 3 sisters, and notice it says solve algebraically. I haven't really said much about that, but when it says solve algebraically, it means we're actually going to use variables and letters to solve this, not just try to guess. Okay, here we go. 3 sisters have ages that are consecutive odd integers. Think about that for a second. Consecutive odd integers. Find the ages if the sum of the age of the youngest and 3 times the age of the oldest is 5 less than 5 times the middle sister's age. Whoa, that sounds ridiculous. All right, so I don't think we have enough information to do this problem, so let's look at the following. Let's talk about consecutive integers, consecutive odd integers, consecutive even. So let's talk about consecutive integers first. Consecutive integers. Okay. Let's try to give an example of consecutive integers. Well, consecutive integers are just that. They're integers that come one right after the other. Let me make a little straighter line here, but let's talk about what that might be. Maybe 1, 2, 3, 7, 8, 9, 12, 13, 14, anything that comes consecutively. No fractions, no decimals, because they're integers, if you remember that. Okay. Now, let's talk about the pattern, because we don't want always these integers. We want to talk about how do we find consecutive integers. Well, we look at the pattern. To get from one integer to the next, we always have to add 1. If we want another consecutive integer, we have to add 1 to 14 and get 15. So if we want to use some algebra, we can let x represent any integer, but then to get to the next consecutive integer, you'd have to add 1 to x. To get to the next one, we'd have to add 1 to that, which would make it x plus 2. So this is the algebraic representation of 3 consecutive integers. What if we don't want consecutive integers? We didn't in this problem. What if we want consecutive even integers? Okay, now this is kind of cool, because after even, we want to talk about consecutive odd integers. And there's a reason I'm putting these up together. By the way, you can have negatives. You can have negatives. Negatives are integers. So like -6, -8, -5. Okay, consecutive even. Well, you might be thinking 2, 4, 6. How creative of you. Or, I don't know, 36, 38, 40. Those are consecutive even integers. Again, they're even integers that come one right after the other. Okay, let's look at the pattern here. Well, to go from one even integer to the next, you have to actually add 2. Then to go to the next one, you have to add 2 again. That's the pattern. You keep adding 2. That's the pattern because we have to step over an odd to get to our next even. So a representation for this, algebraically, would be x, where here x is any integer, here x is an even integer. Well, then my next one would be x plus 2, and after that we have to add 2 again, and x plus 4. If I wanted a fourth one, x plus 6, x plus 8, okay? Because, look, this makes sense. If this was 16, remember it's got to be even. 16 plus 2, that would be 18. 16 plus 4, that would be 20. 16, 18, 20, they'd be consecutive even integers, so that makes sense. Let's go to consecutive odd. Consecutive odd is exactly what you think. It's to have odd integers that come, consecutively. Okay, that next one obviously would be 23, 19, 21, 23. Let's look at the little pattern there. Again, the pattern is the same as the last one. And the reason, remember here we had to step over an odd to get to an even. Here we have to step over an even to get to an odd. So the algebraic representation would be x, where x would be an odd integer, and then add 2, and then add 2 to that. Add 2 to that. X plus 2 would be x plus 4. Now notice, this is really important. This says even. That's not why this is even. This is actually the number of steps you take from one even integer to the next. Look, this says odd, but these are even numbers because they don't represent numbers as numbers. They represent them as steps. How do I get from one odd to the next odd? I got to add 2. So the representation for odd and even is exactly the same. Obviously, for integers, they are a little different because their pattern is always you add 1. So let's see how that helps us do some problems. All right, let's take a look at this. This one says to think about it. We want to know if x and x plus 1 could be two consecutive odd integers. Now, just take a second to think about that and write down what you think in your workbook, because you'll find that this problem there, and then hit the video to continue. Okay, well, if they're two consecutive odd, that means they both have to be odd. So let's just take a look at this. Let's pick any odd number, 7. If we have an odd number here, this means I'm going to add 1 to that number. Well, what kind of number does that have to be? Well, when we add 1 to an odd number, that's always going to have to give me an even number. So these cannot be two consecutive odd. And we kind of knew that because we said the pattern was to add 2. But this kind of shows you why. So even though that's odd, they can't be odd. That has nothing to do with the actual number itself. Okay, it has to do with how many steps you have to move to get from one odd to the next odd. So I hope that clears that little thing up. All right, so you see why these cannot be two consecutive odd integers. Now let's talk about some key information that we need to solve these types of problems. And the types of problems I mean are the problems we saw earlier about those giggling sisters, okay? The truth of the matter is that we are solving consecutive integer problems. And what's cool about them is, yes, we're going to need a key, just like we did in the last lesson, but it's also a lot like the beginning of the last lesson where we did direct translation. So you can look at that key information and read it, but I'm going to do the next problem. All right, before we go back to those that giggling girl problem at the beginning, let's do this problem. Find 4 consecutive odd integers. So here's what we know. We have 4 unknowns and they're consecutive odd integers such that the sum of all 4 of them is 56. So we're going to start with a key. That's the very first step. Okay, there's 4 of them. So we have the first, the second. Remember, they're odd. So the first odd, the second odd, right? They're odd. The third odd, and the fourth odd integer. The first one, whether it be even, odd, regular integer, is always x. If they're odd or even, remember we have to go up by 2. X plus 2, 2 more, x plus 4, 2 more, x plus 6. That would be either consecutive odd or consecutive even. Consecutive integers, just regular consecutive, would have been x, x plus 1, x plus 2, x plus 3. So here's where we are. Once we have this key right here, do not touch the key as far as changing anything because of these words. The only time you'll come back to the key is after you find out what x is. Because now we're going to go direct translation with this key. So here we go. Okay, so 4 consecutive odd integers such that, okay, the sum of all 4 of them is 56. So here's the equation. The sum of all 4 of them is 56. There's the equation. Well, how do we show the sum of all 4 of them? That means to add up all 4 of them. So x plus 2 plus x plus 4 plus x plus 6 equals 56. The sum of all 4 is 56. That's where that came from. Now we just solve this. 1, 2, 3, 4 x's. 6 plus 4 is 10, plus 2 is 12. This is so cool. I love these. Now listen, sometimes you have a key and you don't even use every single one of these in the equation. It's really kind of cool. Okay, we subtract 12. We subtract 12. 4x equals 44. Divide by 4. Divide by 4. X is 11. Now, first thing you want to be aware of, they have to be odd. Well, that's odd. So far, the first odd integer is 11. So here's 11. Then 11 plus 2 is 13. Here's your next odd. 11 plus 4 is 15. Here's your next odd. And they're supposed to be consecutive, and they are consecutive odd. 11 plus 6 is 17. There's your odd. And now we have 4 consecutive odd integers. That part is checked. We know the sum of them has to be 56, so we just add them. 17 and 15 is 32. 32 and 13 is 45. And 11 is 56. Checks out. Your check is almost in your head. Just make sure everything checks out, just like all verbal problems. So cool. All right, that's the end of that problem. We can move on to the next one. All right, let's take a look at this one. The sum of 4 consecutive integers is 1 more than the third. Find them. You can find this on the slide. You can find this in your workbook. What I'd like you to do is just set up the key and set up the equation that you would use to solve this. Do not solve this problem. When you're ready with the key and the equation, we'll, hit the video and we'll continue. All right, so there's 4 consecutive integers, not even, not odd, just integers. So here we go. Here's the key. We got the first, the second, the third, the fourth. In the first box, yes, should always get x. Now they're consecutive, so they go up by 1. So we get x plus 1, x plus 2, x plus 3. Okay, so there's your key. Let's look at the, look at the equation. The sum of 4 is 1 more than the third. That's what we're looking at. That's where the equation comes from. Word for word. I don't have to think about it. I don't have to think about, oh, which one do I make x? Which one do I do this? We're just going to go like this. We're just going to write the problem down and just plug it in. It's very quick. Okay, sum of the 4 of them. The sum of the 4 of them would mean to add these up. That's the sum of the 4 of them. And that is equals 1 more than the third. The third one is x plus 2. Word for word. Don't worry, I used that there. It doesn't matter. Just go word for word. Okay, so 1, 2, 3, 4 x's plus 6 equals x plus 3. If you're wondering where I got the 3, 1 plus 2 is 3. Okay, solve. I'm going to start with the variables first. That's minus x, or 1x, which is 3x, plus 6 equals 3. Ready? Subtract 6. 3x equals, it's okay, 3 okay, up. 3x equals negative 3. I was ahead of myself. I knew what the answer was. 3x equals negative 3. It's okay to get a negative. A negative is still an integer. Let me put that here. Divide by 3. X equals negative 1. Awesome. So we know what the first integer is. It says there are 4 consecutive integers. I don't care if it's even or odd. So here's negative 1. Here's negative 1. Oops, that's ugly. Negative 1 plus 1, which is 0. Negative 1 plus 2, which is 1. Negative 1 plus 3, which is 2. So these are our consecutive integers. Negative 1, 0, 1, 2, just like on a number line. Negative 1, 0, 1, 2. If you give me a second, we will do the check. All right, this is a very cool check. Stay with me. The sum of the 4 of them, so let's do the 4 of them. Negative 1 plus 0 plus 1 plus 2. Well, that's just 2. That's the sum of the 4 of them. Sum of 4. Okay, that's supposed to be 1 more than the third. Here's the third. Is this 1 more than the third? I do believe it is. That's the check. So it all checks out. That is such a beautiful thing. I love that question. All right, we're going to try another one. Take a look at the slide in front of you, which is also in your workbook. It says, write the following in terms of x, then simplify. 1/2 of the sum of 2 consecutive even integers. I want you to think about how this is different from the other problems we already did. So take a moment to think about that, write it down, and click back when you're ready. Okay, well, if you recall, all the other ones that we've done so far said solve algebraically. We're not solving this. It says write the following in terms of x. All we're doing here is making an expression. So let's see if we can do that. It says 1/2 of the sum of 2 consecutive even integers. So I am going to still give me some kind of key because I want to talk about the 2 consecutive even. Okay, first even. I'm going to clean up this board a little bit. Okay, second even. Remember, the first one's always x. Because it's even or odd, we go up by 2. To get from one even to another even, you got to take 2 more steps. Okay, and now it says 1/2 of the sum. 1/2 of means to multiply the sum. Operation followed by an operation, we need a parentheses. The sum means I'm going to be adding something. And I'm adding the sum of the 2 consecutive integers. So I'm adding the sum of the first integer with the second integer. That's how that looks. So I have 1/2. 1x plus 1x is 2x plus 2. So that's what I have, and it says simplify. Now this is really important. Think about this. I cannot clear the fraction. Do you know why I can't clear the fraction? I cannot clear the fraction. I'll tell you. I cannot clear the fraction because it's not an equation. There's nothing to keep in balance. So I must distribute this. I must take 1/2 of it. 1/2 of 2x is just x. Positive times a positive is a positive. 1/2 of 2 is just 1. So my answer is x plus 1. Nothing to solve there. Just write the following in terms of x. Here it is. It's not set equal to anything. I cannot solve it. I am done right here. That's how this problem is different. Okay. Let's go to the next problem. All right, take a look at this next problem. 1/3 of the sum of three consecutive integers, is 0. What are the integers? I'm not going to do that one for you. I want you to take a look at it. I want you to set it up and you to even solve this one. So go through the whole thing, remembering everything we know about verbal problems and about this type of problem, and then click the video when you're ready. All right, let's see how you did. So we got just regular integers, right? So we got 3 of them. So first integer, second, you know it's an integer. I'm not even going to write it. Third integer. We know the first one's x. They're consecutive integers, not even or odd. So I'm going to go up by 1. So the second is 1. Third is 2, because I add 1 to that and get 2. Notice again, I don't touch this again until after I get my answer. Now it says, and that's a really bad line. I'm going to try that again. Okay. That might be bad too, but that looks a little better. Okay, it says 1/3 of the sum. Okay, 1/3 of the sum. So of is multiplication followed by another word, sum, okay, operational word. That means I need parentheses. So 1/3 of the sum of the 3 consecutive integers. Okay, so we got to do the sum of the integers. And it says that is 0. So that's what I have. So let's take a look at this now. Order of operations, I'm going to clean this up. I get through, oh, look how nice I was to you. 1/3 of 3 is 1/3 times 3, or 3 divided by 3, which is just 1x. Positive times a positive, positive. 1/3 of 3 is 1 equals 0. Subtract 1, we get x equals -1. Again, we get a -1. So -1 is my first integer. -1 plus 1 is 0. -1 plus 2 is 1. So we have -1, 0, and 1 as my 3 consecutive integers. Now 1/3 of the sum is supposed to be 0. Let's check that out. Well, here's the check. I'm going to put it right here because it fits. Here's my check. 1/3 of the sum. Well, the sum is -1 plus 1 is 0, plus 0 is 0. 1/3 times 0 is 0, so of course that checks out. So my answer, my 3 consecutive integers are -1, 0, and 1. I am done. Great problem. All right, I think we know enough now to revisit those giggling sisters in the challenge problem. Okay, they have ages that are consecutive odd integers. So the first one is going to be, the first odd is going to be x. The second odd is going to be x plus 2. The third odd is going to be x plus 4. Okay, now let's see what it says. It says find the ages, the sum of the age of the youngest and 3 times the age of the oldest. Okay, so we're talking about youngest, oldest, and middle. So let's kind of designate who's who. Obviously, this is the smallest number, so this is the youngest. This is the biggest number, so this is the oldest, because this is 4 more than x. Okay, and this is the middle kid. Okay, so now let's see what we got. Again, don't go back to this until you have an answer for x. Do not touch this. It's direct translation now. Okay, the sum of the ages of the youngest. Okay, the sum of the ages of the youngest. Oh, youngest. I'm spelling the way I write right now. I mean the way I speak. Okay, sum of the youngest, I'm going to write this down just so you can see it, sum of the youngest and 3 times the oldest, and 3 times oldest is, okay, 5 less than 5 times the middle. 5 less than 5 times the middle kid. Okay, this is important because you want to see some keywords going on here. Okay, so the sum, that means to add. Here's the and. Here's the is for the equal. So sum of the youngest, which is x, plus 3 times the oldest. The oldest is x plus 4. The youngest plus 3 times the oldest. There's the oldest is, okay, now let's be careful here, less than. So whatever comes after the less than goes first, but it's got to be after the equals because it's after the is. 5 times the middle. The middle is right here, x plus 2. Here's 5 times the middle, and you're 5 less than that, minus 5. Okay, so here's what we have. The sum, now I can not even read that. I can see what this is saying. Watch. The sum plus of the youngest plus 3 times the oldest is 5 less than 5 times the middle. Here's 5 times the middle. Here's 5 less than that. If that doesn't make sense, ask your instructor, but let's move on. So now we're going to distribute. Positive 3x, positive 12 equals distribute 5x plus 10 minus 5. And we have 4x plus 12 equals 5x plus 5. Here we go. We're almost home. Subtract 5x. We get negative 1x plus 12 equals 5. I'm going to have to cut off a little room here. Negative 1x plus 12 equals 5. Subtract 12. Subtract 12. Negative 1x equals negative 7. Divide by negative 1. We're home free here. X equals 7. So here's 7 for the first kid. 7 years old for the first sister. 7 plus 2 is 9 years old. And then finally for the oldest kid, 7 plus 4, 11 years old. Pretty cool. Now, let's take a look at the check. All right, let's take a look at the check. We know that consecutive odd, that checks out. Now we have to make sure this is going on. The sum of the youngest and 3 times the oldest. So the youngest is 7 and 3 times the oldest. So that's 7 plus 33, because 3 times the oldest is 33. 33 plus 7 is 40. So we know that's 40. That's supposed to be 5 less than 5 times the middle. Kind of erase the middle person. 5 less than 5 times the middle. Well, 5 times the middle is 5 times 9, which is 45, and this is 5 less than that. Checks out. So you can do that in your head, or you can just kind of do some arithmetic on paper. But this checks out. So the youngest kid is 7, the middle kid is 9, and the oldest kid is 11 years old. Great problem. Awesome. Okay, we're going to look at one more in a minute. All right, we got 2 left in this section. Let's take a look at this one. We want 3 consecutive integers such that the difference between the first and the third is 98. Okay, what I'd like you to do is I'd like you to go to your workbook, okay, and set this up with the key and the equation, and then click when you're ready and we'll solve it together. All right, you ready? Here we go. 3 consecutive integers, so they're just regular consecutive. So we got the first, the second, the third. And the first one by now is always x. Even if you don't know what you're doing, first one's x. Okay, consecutive goes up by 1. If it was even or odd, that would be a 2, right? Okay, x plus 2 for the next one, you add 1 to that. Now, don't touch that key until you get your answer. That's what it says. The difference, that means subtract. Whenever it has the word difference, sum, product, difference, sum, product, what's the other word? Quotient, we know we need an and that tells me where the operational symbol goes. So here's the and. So there's your minus sign. It's going to go right here. Okay, so let's see what we got. The difference between twice the first, and remember, you don't change the order here. Twice the first, which is 2x, and the third. Now, here's where we have to be careful. The third has to be put in parentheses. Let's talk about why it has to be put in parentheses. We're subtracting that whole thing. In algebra, that's going to mean we're going to have to distribute that negative. If you don't know when to put the parentheses, put them in all the time and don't worry about it. But you absolutely need this parentheses. This one's optional, but this one has to be there because twice the first and the third has two terms in it. I have to subtract that whole thing. That's important. Is 98. Now never simplify anything or start solving until you have all the parentheses off. So this is just 2x distributed into negative 1, negative 1x minus 2. And then it equals 98. 2x minus 1x is x, minus 2 equals 98. We'll add 2. X equals 100. Now, let's see what we got. This is 100. This is 101 because it's 100 plus 1 or 101. This is 100 plus 2 or 102. Those are your three integers. If we did it right, it will check out. Let's check the check. Here we check the check. I love it. Here we go. The difference between twice the first. Well, twice the first is 200. And the third, which is 102, that's supposed to be 98. And it is. Twice the first minus the third is 98. There you go. All checks out. Pretty awesome. Okay, so it looks hard, but this is the hardest part. Don't forget the parentheses. We're subtracting that whole entire thing. Okay, very important. We have one problem left in this lesson. All right, this is the last problem. It says putting it all together. We're making sure we understand all of this. So we want to solve this algebraically. Again, I want you to do me a favor. I want you to go to your workbook, set up the equation, set up the key, and then click back when you're ready. Okay, here we go. 3 consecutive even integers. So they're even. First even. I don't know why I make that line so big. I don't really need it that big. But second even. Third even. Even. X plus 2. Not because 2 is an even number, because to get from one even to the next even, we've got to move 2 spots. Okay, 2 places. Take 2 steps on the number line. Add 2 more, we get x plus 4. Let's try that again. X plus 4. Okay, so now it says 3 consecutive even integers, that's great, are such that the sum of the second and the third. Don't touch that, remember. Okay, the sum of the second and the third. Okay, sum tells me to add wherever the and is, that's where I put the plus. So the second, which is x plus 2, and if you want to write that here, you can, and the third. Okay. The third is x plus 4. If you want parentheses, you can write it. You don't need it. We'll talk about that. Is, there's your equals, 6 more than twice the first. Twice the first. Twice the first. The first is x, twice the first. Now, you used all your integers. You don't I think almost in every problem we used every integer. Sometimes you don't. Okay, don't get crazy if you don't. Again, you don't really need parentheses here because they're non-essential. There's a plus in front of them. So this is just really x plus 2 plus x plus 4 equals 6 plus 2x. So if you just wrote that, that's fine. Now we're going to solve this. This is 2x plus 6 equals 6 plus 2x. Oh, this is a very cool problem. Oh, you have to go back to, I don't even remember what mod you have to go back to, but this has been in the homework a lot. What happens now? Do you remember our variable dropped out? Well, if our variable drops out, you got to stop. You got to see if it's true or false. It is true. This is an identity. That means that all real numbers are your answer. What does that mean for us? It means that any 3 consecutive even integers will work. Any or all 3 consecutive even integers. That's what that means, that any 3 will solve this. I can't really prove that because I have to prove it for all 3, and there are infinitely many 3 even integers, but I'm just going to show you what we mean. Let's pick 3 even integers just off the top of our head. Okay, and again, this is not really the check. I just want to explain what's going on. So there should not really be a check here, because you can't check all all the integers that this works for, but I'm just going to show you what this is saying. So this is my head. This is going on in my head. In my head. This is my head. My head. Here's what's going on. It means that if I take any three integers, so let's take, they have to be even. Let's take 10, 12, 14. Okay, here's what it says about it. It says the sum of the second and the third, the sum of the second and the third is supposed to be 6 more than twice the first. What's twice the first? 20, 6 more, 26. See, it works. See? Cool. Let's do it again. One more time, just for fun. Okay, let's try 200, 202, 204. Okay, it says the sum of the second and the third. That's the, second and third? Yep, second and the third. That's 202 and 204, which is 406. That's supposed to be 6 more than twice the first. What's twice the first? 400, 6 more, 406. It will work with any three consecutive even integers. That's why that's the answer. It's an identity. How cool is that? My favorite problem. So cool. All right. That takes care of that lesson. All right. Let's get ready for lesson 5.